As we continue going through the year, our equations will start getting slightly more and more complicated. Instead of just having one variable, we might have two. We might have 1, 2, 3. We might have 1, 2, 3, 4. In algebra, we can start making as many variables as we need to explain the world around us. And we can still be solving. So now, we can technically solve for an equation that looks like this. Now solve, guys, is just a fancy way to say isolate. So if the directions for this first problem we're about to do is solve for A, that means I want to isolate A. So whatever I'm looking to solve for A, I'm gonna circle it out in my equation, and I know I need this totally isolated and alone on this side. So I see the 3 and the K. Now we're still gonna use our inverse operations as if it was a problem that looked like this. Instead of the 5, we're dealing with a K. But the thinking is going to be the exact same. If we wanted to solve this problem here, we would start by subtracting the 5 from both sides. So over here, we're gonna start by subtracting the K from both sides. We'll have 3A come on down equals. Now, 4 minus K, are those like terms? Remember, like terms have to have the same variable. Since that's a K and that's a number, I can't combine them, so I'm gonna write them next to each other, 4 minus K. Now if we go back to this example, we know that we could do the 4 minus 5 to get us a -1. And then if we're still solving for A, I'm gonna divide by 3. And in this problem, A will equal -1/3. Over here, I'm still gonna do the same thing. I'm still solving for A. So I'm gonna divide by 3, but I'm gonna divide the whole thing by 3. So A will equal 4 minus K over 3. As when you're asking to solve for A, as long as A is alone, this is totally correct. You're not gonna get A equals a number, you're gonna get A equals sort of an algebraic expression here. Same thing. As we solve for a variable, solve for A, that means isolate A. We want A totally alone. And we just have to think about our inverse operations that we've been doing such a good job with. So I see here I have 32, B, and A. There's nothing in between the 32 and the B or the B and the A. So that means that this is multiplication. 32 times some number B times some number A. So what's the inverse operation for multiplying? It's division. Now we can do this problem in 2 different ways. So I'm gonna write this down twice and show you guys how to solve this 2 different ways, okay? In both problems, we're solving for A. Now I know over here, I have the 32 and the B being multiplied with A. So if I want, I can divide by one thing at a time. So the 32 goes away, and I'm left with G over 32 equals BA. Once again, BA is multiplication, so we'll have to divide. And look at here, we already have a denominator. So I'm not gonna draw another division symbol because that looks kind of crazy. What I'm gonna do is just write that B down with the 32 already. Because anytime you have numbers in the bottom of a fraction, that stands for division. So our final answer will equal G over 32B. As long as A is alone, we've officially solved for A. And so in this case, I divided once, twice. And whenever we divide, we just put that number or that letter in the bottom of the fraction, and that means division. Now if you wanted, we could have done that in just one step. Since that's 32 times B times A, I could have just straight up divided by 32B instead, and then boom. That jumps right to the final answer. Now, we're gonna make this slightly more complicated, okay? All we have to do is keep in mind our good inverse operations, and we can start doing a problem like this. Solve for X. So I'm gonna circle what I'm being asked to solve for, because now everything needs to be isolated. I need everything away from that x. So I see an 8 that's attached really, really close. Then I have this 4, negative 9m, and 9y. Now none of these can be added or subtracted together because they all have different variables. None of them have like terms. None of them are. So we need to get rid of 9y, negative 9m, and negative 4 one at a time, and then we'll deal with that 8. We always keep that close number till the end. So that's positive 9y. I'm going to subtract it from both sides. Z and y are not like terms, so I'm going to write z minus 9y together equals, that goes away now, negative 9m plus 8x plus 4. Now I'll get rid of the 9m. Now over here I have a z, a y, and an m. None of those match, so none of those are like terms. So I'm just going to write them side by side. I'm still saving that close 8 until the very end. So now I'll subtract the 4. There isn't a regular number over here, so once again, there's no like term for that regular old 4. So I'm just going to write it next to everything else. And now that is 8 times x, so the opposite is division. So we can write it like this. We can divide every single thing by 8 like that. Or if you want to be a little bit lazy, we can do this. You can just write one huge division divided by 8. The 8's cancel, and now we're left with our good final answer there, because our x is totally alone.